Ladies and gentlemen, Luxology Chief Scientist, Alan Hastings.
You see, that's why we love Alan. He doesn't have a lot to say, but when he strolls in the room, you know something cool is going to happen. That's Alan. It's nice to work with geniuses, I'll tell you that. And it's been a fun ride working with these guys at Luxology. Having a team put together with such experience and vision and passion has been wonderful. Obviously, we have a lot of stuff to show you tonight, some really cool technology, some little sneak previews there of some things to come. We're going to talk more about that. But first, I want to give you a quick snapshot on Modo. Most of you are probably here because of Modo, right? Love that Modo. As you probably know, Modo 102 combines cutting-edge tool set, advanced software ergonomics, painless pipeline integration, so it drops right into whatever pipeline you're working with, and a streamlined learning curve. And the great thing about that fusion is it really makes Modo an efficient and fast modeling application. But you know what? I know you guys don't care about marketing crap. You want to see technology. So I'm not going to sit here and bore you with slides with people like Darren Grant, the Director of Technology of Digital Domain, who happens to have great things to say about Modo. I'm not going to bore you with the news that we're moving Modo to Linux for Disney. I'm not going to talk about that. I'm not going to talk about the fact that the press has such amazing things to say, like we're the best tool for subdivision surface modeling. You don't care about that. You care about art and technology, and that's what we're here to talk about. So first of all, I do want to give some props to our users because they deserve it. This product's only been on the market for about 10 months, and already they're creating amazing pieces of art. We just got the one in the middle there from Jose Perez recently, who's doing a lot of the modeling for Stargate Atlantis. Amazingly detailed models these people are putting together. And considering this product is 10 months old, that they've been able to grasp it and run with it and create such stunning pieces of art is a real testament to their artistic and technical skills. And we want to say thank you to that community. That community also with third-party sections like Vertex Monkey, where you can go and get free training, free scripts and macros to extend your Modo configs. Modo is designed to be very extensible, and there's all this stuff that the community is building and just giving away to each other. There's this amazing sharing community. So that's where we are, or that's where we were with Modo 102. First, I want to talk tonight about modeling. And I know there are a lot of modelers out there who love Modo because it's a pure modeler. And so we want to talk to you about what we've been doing recently, our modeling advancements, or as you would say, what have we done for you lately? What have we been up to? And there's a lot of work that's been done in just pure modeling technologies, and we want to talk about some of those things tonight. Here's one, an oft-requested feature on the forums, a slide tool, an edge slide. I picked this one out specifically to make a point, and that's that when we set about implementing a feature, we hear your requests, we listen to what you're saying, we actually think about what you're saying and don't just implement it generically so that it would be just an edge slide that we could tick that off our feature list. We go a little bit further and we say, you know what? What if we wanted to not just slide on the perpendicular edge, but any guide edge? So you can now slide, click an edge, and slide along that edge, any edge in your mesh. You can also take and slide non-edges. Okay, so we said the feature request was edge slide. Why edges? Why not be able to slide vertices? Why not be able to slide polygons also along those edges, also using those guides, okay? So the point here being we take an implementation or a request and we go beyond the expectations, fill it out into a robust functionality. And of course, because of the tool pipe in Modo, We can combine that with any of our existing fall-offs. No extra work for us. When we add a new tool, it just works with the fall-offs. So here you see, now you can do edge sliding modulated by a linear fall-off, or modulated by a cylindrical fall-off. Or heck, you can use, did I just say heck? Heck, you can use the airbrush fall-off to actually paint edge sliding onto your model. All right, that's the power of the tool pipe. And again, a fairly simple feature, but I wanted to pull that out so that as we go through other features, keep in your mind, this is all integrated into the tool pipe, which gives it a much greater impact. We had a lot of goals. As a subdivision surface modeler, one of the most important things is creating the base mesh, right? And often that base mesh is a cube, and then you subdivide it out and you add details in. Well, what if we wanted to make that a little easier, extend that a little bit? So you don't just want to start from cubes, you want to start from something a little more interesting. So we added in a tool that we call Solid Sketch. And Solid Sketch, it sort of defies description, so why don't I just show you a little bit about Solid Sketch. We're going to activate the tool here, and I'm going to go ahead and turn on symmetry. And the idea is that you want to quickly rough out a shape, right? So we start off, that's typically what we start with, a box subdivided and turned into sub-D, so that's nice. But now we want to add some nodes here, so we'll just add those in. And not only will I demonstrate Solid Sketch for you, I will demonstrate my lack of artistic skills. But what we want to do here is just build out a quick framework for something maybe like a lizard or something. So we do this, and you see very quickly I can just rough out the shape. And the great thing about that is once you've got the rough shape, as you know, Modo has all the tools you need to then go in and add that extra detail to finish it off. Now each one of these nodes can be edited interactively after the fact. Come over here, we can change this position. We're going to go ahead and grab this guy here. Let's push that up a little. We make kind of a head. And of course, at the hands of a real artist, over time they're going to come up with something beautiful like this. I could have done that. It's just hard to do it in real time. We had another goal, which was to accelerate the addition of detail geometry, right? So you've got your base mesh, and you add the details to it like we've done with the lizard there. But you may want to add other things like horns or bumps, or let's say you're working on the side of a boat, you want to add some rivets, and you just want to stamp them down easily. So we wanted to simplify that process, accelerate that process. And for that, we've created a tool called Mesh Paint. And I'd like to show you that as well. Very useful for adding details. So what we have here in our little lizard, if we look at the other layer here, you'll see that I have this tiny little kind of horn thing that I've made. And I'll go back to this layer here, and we'll activate Mesh Paint. Okay, and currently we'll set it to slide mode. And you'll notice that when I click and drag, I can just place that little guy anywhere I want. So if I want to place a couple horns on him, I can easily just go click, click, and that's done. But remember the tool pipe, integration with the tool pipe. So let's see what happens there. Let's go ahead and zoom out here, and I'm going to add a fall off. It's going to be a linear fall off. And we'll just go ahead and choose the fall off there. There we go. And so the fall off at the tail is 0%, and at the head it's at 100%. And we're going to choose our Mesh Paint. And now in my Mesh Paint options, I'm going to choose Use Fall Off for the size. Okay, so watch what happens now. I click this down, and watch as I go down the tail, it automatically scales that according to the fall off. So I can then just go in and say, okay, I want some hairs in here, and I actually want them to scale down as I go. I can also say change from slide mode to stroke mode, and then we can just go up here, and I can just start to paint those guys on quickly. This is great for doing things like trees, shrubbery, anything where you have to just quickly paint some detail onto your mesh. So that in and of itself is pretty cool. But I've actually been demonstrating two different features at the same time. I've been showing you Mesh Paint, but we've been leveraging another new technology that we've added into Modo. And let's take a look. So I'm going to turn off my fall off here. And let's just go ahead and split our viewport. Now again, remember that little mesh I had down here? Let's go look at that guy. There he is. Notice some nice rollover pre-highlighting. That's nice. Okay, so I'm going to take that guy, and let's just use, say, Element Move, one of my favorite deformers, and start to tweak that guy. Now what you'll notice is, as I tweak that one little hair, or horn, I'm moving all of them. So we now have true mesh instancing, per your request, directly inside of the Modo toolkit. Okay? And it's not just for transforms, so I can go in here and bevel that guy, and we'll just zoom in and choose these polygons. Hey, there we go. And let's see a little bevel action. So you can see we can also do geometry additions. So we're just adding some extra spans there. Stretch that out. And now you see we've gone from the simple little guide hairs to more complex prongs. So there we go. So that's our solution for adding details to a mesh. And as I say, we also reveal true mesh instancing. And those mesh instances can have their own positions, scales, rotations, textures, what have you. It gives you a great simplicity in adding details and then going back and changing the original. If you've got a camera body with hundreds of screws in it, you can go and tweak that first screw and all of your screws update. Also makes it much more efficient for OpenGL and memory consumption. Another goal we had was to add additional interactivity to some of the key tools. One of our messages about tools is they're always interactive, but you know what? Some of them weren't. So we wanted to make sure that we could improve that. In particular, things like curve extrude, curve clone, rail sweep. We thought we could do better. But instead of just going and fixing those tools specifically, again, our CTO, Stuart Ferguson, is always pushing us on architecture, always pushing generality. So our solution was to build a system of what we call generators and effectors. And I'm going to show you how that works. It's easier to show you than it is to talk about. So the generators and effectors are just a simple system that allow us to essentially build what I would call particles or 3D locators in space. And then what we can do from there is we can composite that with effectors that tell it what to do with those generators, those generated points. So here we've got a basic little treasure chest. I wonder what's in that treasure chest. It's probably treasure, is my guess. We're going to go over here, and I'm going to activate curve clone. Okay? So there's curve clone. And you see in the tool pipe, look over here in the tool pipe on the far right of your screen. Instead of just a curve clone tool, it's actually a stack of tools. It's a curve generator, a path generator, and then the effector clone. So if I go in here and I activate my curve generator, what it's doing, the generator is creating the curve, and then the effector is affecting the instances, or excuse me, the cloning. So this is creating real geometry cloning there, and you can see that we can then, of course, interactively move those things around. But there's another way we can do this. So I'm going to go back over here, and what I've done is I quickly swapped out effector clone, but I've changed it to effector instance. So now when I create my curve, it's actually generating instances. Now at first glance that doesn't seem much of a difference, but you'll notice that instances, of course, give us a much better performance. Now another side benefit to the system is that the general nature of those components, the curve generator, the path generator, can be extended. So you have a cutter tool that reads the curve input, and now you have a spline-based knife inside of Modo. We didn't have to go code up a curve clone and a separate knife spline, right? We created the generic element of a curve generator, the generic element of a clone effector, and then the simple generic effector for cutter, and now we can cut things with a spline. Again, the benefit of programming through generality and compositing those tools through the tool pipe. We had another goal, which was an unprecedented control over reduction of mesh density. So far I've been talking about adding details into the model, but a lot of people actually want to pull detail out, also known as polygon reduction. Now, it would be easy for us, again, in the mentality of just ticking off a checkbox to go out and get some standard algorithm and implement it as a command that you fire and tell it roughly how much you want it to reduce, and then it gives you the results, and you see if it's good, and if it's not, you undo it, and you redo and undo and redo and undo and redo. No. We wanted to create something better. We wanted to create a polygon reduction tool. And again, remember the implications of the word tool as it applies to Modo. So what I'm going to show you now is how we've implemented the polygon reduction tool. To do that, I'm just going to use some fairly simple geometry just to illustrate the point here. Let's just go ahead and build up a cylinder, and we'll zoom in. All right, now I'm going to go into the geometry pull down, and we'll go ahead and go with reduction. Now when I click, you'll see in my numeric properties here, it shows me 290. That means there's 290 polygons in the mesh. If I'm working in a game house and I know I have a specific budget for my asset, I can type that in. I have 150 polygons available. There it is. That's 150 polygons. Done deal. If, however, I just want to reduce it as far as I can and still have it look good, click, drag, and watch the reduction happen. Okay? So that's an interactive polygon reduction tool. But what else about tools? Tools respect the tool pipe. So, cylinder fall off, geometry reduction, click, drag. Now watch what happens. Move the fall off around, isolate your polygon reduction to any portion of your mesh. Again, I'm talking about generality here. Those fall offs, we have all kinds of fall offs, linear, airbrush, weight map. So you can create a vertex weight map on your mesh that says, these hot spots are where I want to reduce the geometry. These spots that are 0, don't touch them. Drag and see your results. Another goal, distortion-free textures on subdivision surface meshes. If you don't know what that means, it sounds like gobbledygook. If you know what it means, you say, finally. Look closely at this texture. Can someone tell me what's wrong with this picture? All the texture in the middle, this is actually a cylinder again, UV'd with sub-Ds on. So that top polygon, that's a single polygon. And fortunately, our N-gon poly, or N-gon subdivision surfaces, handles it beautifully. What it didn't handle beautifully was the texture inside. Horrible interpolation. A lot of systems have this problem. Well, we've implemented automatic subdivision surface interpolation. The beautiful thing here is you don't have to pick an algorithm. It matches the algorithm of our subdivision surface limit surface. You hit tab, your mesh is smoothed, your UVs are smoothed, nobody gets hurt, everybody's happy. See, my marketing people were like, they're not going to, smooth subdivision interpolation, what? Skip that. It's good stuff. You guys get it. All right. Another goal was to dramatically improve the interactive experience for the user. I mean, what better way to learn software than to see the results happen as you work, right? We all know this. How many people have been doing 3D for more than, say, 5, 6 years? How many people have been doing it since before you had OpenGL? Remember that? Boy, that sucked, right? It was bounding box city or some sort of flickering vertices and trying to guess where things went. We can create so much faster now because of OpenGL. And so we wanted to do something even beyond our current state. Modo 102, well known as one of the fastest in its class for OpenGL drawing. And we said being head of the class isn't good enough. We want to set the bar higher. We want to create an entirely new class. And so what I'm going to show you tonight are some advanced OpenGL functionality. And I want to give some props real quick to ATI. We have a FireGL card in here. And this is the great thing about our implementation, is that it's advanced enough that if you have the power in your card to take advantage of some of these new advanced GL functionality, it just happens automatically. And I'm going to show you what the net result of that is now. Because as we know, mesh density is increasing all the time. So we need to be able to manipulate much, much heavier geometry. So what I'm going to do here is I'm going to load up a mesh. And this is a Noble from one of our end users. He built this in Modo. It's a beautiful model. It's apropos that we're going to show off the high-speed engines of our OpenGL with a high-speed, beautiful automobile. This is about 600,000 polygons. And we chose this model because of 2 reasons. One, because it's heavy and it's beautiful, but also because it's a combination of raw polygons and subdivision surfaces. So about half of it is in raw polys and half of it is in subdivision surfaces. And the net result is that more than 500,000 polys, 600,000 polygons. And you know, navigating that can be somewhat slow sometimes. I think our interactivity is a little bit better. Okay? So this is the advanced OpenGL. You can see here, we can zoom around. Changing layers is instantaneous. Changing drawing styles, something just as simple as switching from a wire to a reflection mode can take several seconds in some systems. Here, it's instantaneous, wire to shaded, to textured, to reflection, to weight map, to wire, to shaded again. All right? But it doesn't stop there. We can also do things like splitting viewports, creating new viewports. But also, we've added another mode that leverages this GL mode, and this is called item mode. So we can now work in a component, vertices, edges, and polygons, or in a sum total mesh item mode. And what that means is we have this item handle here. Notice when I go ahead and click and drag, I can also transform this guy with the same smooth GL performance. All right, so item mode allows us to really accelerate the movement of entire meshes and mesh layers. So that is the advantage of raw horsepower. But what's horsepower without some beauty? So I'm going to load up something else here. I'm just going to bring in a little scene. This was created by a good friend of ours, Andy Brown. You may have seen him on the forums. Guy is a monster. Just creates all kinds of cool stuff very, very rapidly. And what I'm going to do here is I'm going to go ahead and select a few layers. Let's close our Noble. There we go. All right. And let's just zoom in and see what we have to see. Well, what you see is multi-texturing, real-time bump mapping, per pixel lighting, and still butter smooth. So we can really get a much better view of what's happening in our scene as we work inside of Modo with this advanced OpenGL. That's good stuff. Obviously, you saw Alan doing some real-time bump map painting in our painting system, and I'm going to talk about that in a little bit. I just think that's so cool. Doesn't hurt having fast graphics cards, I can tell you that. So that's some of the modeling advancements. We've got a lot more than that. I can't go through all of it tonight. We've got a lot to cover. We've got 3 other squares to cover, after all. What are all those squares? You ask. I'll tell you. So another component to modeling is UV mapping. Who here loves the UV map? Okay. Me neither. It's bad. UV mapping is bad. Now, granted, that's an industry-wide thing, okay? And by industry standards, Modo is pretty darn good at UV mapping because you have all of your basic tools and all your fall-offs can work on the UV map just like it can on your regular geometry. But you know what? It still sucks. Something had to be done. So I had some meetings with our guys, called our Tokyo office and said, what are we going to do about this? What can we do about making UV mapping easier? And let me just show you what I think is a better way to UV map. So it should only take about an hour and a half because I'm going to go ahead and UV map ahead. All right, so let's start here. So far, pretty easy. Let's go ahead and turn on symmetry so we can select these guys. Okay, and let's go ahead and take a look at a UV view here. And let's say we don't UV the eyes right now. All right, is everybody with me so far? I haven't lost anybody in the UV mapping process? Okay, so how do we go, where do we go from here? Well, let's activate this tool. And I think the way that UV mapping should be done is click, drag, done. And this solver is pretty cool because you can do it interactively. You can see the change as we go through. You can actually watch it. You know, you can imagine us doing this by hand. You start here, you do your projection. Now manually start to unfold it. Well, I don't have to anymore, so I'm not gonna. There you go. Kind of makes you mad. You had to do it any other way, actually. So that's our UV mapping. Click, drag, done. So that's modeling, that's UV mapping. Oh, that's UV unwrapping. I've seen some tools that'll do that. Oh, like $1,000, craziness. 3D painting. Well, Alan gave you a little teaser earlier of the 3D painting. So I'm going to talk about the 3D painting component now. In fact, let's just do a quick demo here. Let me go ahead and close out Modo and launch up some painty goodness. So here we have a little castle object. It's got some good surfaces for us to paint on. And what I'm going to do is I'm going to go ahead and change my layout here. All right, there we go. And we'll go ahead and set a color picker there. Now, we'll go ahead and bring up some tools here. We'll start with the paint. Now notice the paint tools here. Just like other tools, these are integrated into the tool pipe, okay? So the way it works is we composite the elements of our painting system together through the tool pipe. So we start with an airbrush, and then I add on, do I want it to be a smooth brush or a texture brush? We'll go ahead and go with the texture brush. And we'll just kind of zoom in over here. Let's go on the side. And we'll say, you see our real-time bump map. That's kind of cute.